In trigonometry, when we're working with right angled triangle like this one, there are three ratios we can form. So here I've got a nice right angled triangle, and the bottom left corner of my triangle is a right angle. And trigonometry is all about the relationships between pairs of sides in that triangle. So if I use this as the angle I'm concentrating on at the moment, this angle down here, there's a convention that allows me to label these three sides. If this is my angle, we can say this side here is adjacent. It's adjacent or alongside that angle. This side here is opposite the angle. It's directly opposite the angle. And the third side, remember from Pythagoras, the longest side in a right angled triangle, the one that's in fact opposite the right angle, is the hypotenuse. So for any right angled triangle with these three sides, adjacent, next to the angle we're talking about, opposite the angle we're talking about, and the hypotenuse, we can look at the relationships between pairs of sides. So let's pick a pair. The first pair I'm going to pick is the opposite and the hypotenuse. The relationship between the opposite and the hypotenuse for this angle we call the sine of the angle. So the sine of the angle is the opposite divided by the hypotenuse. Let's pick another pair, the adjacent and the hypotenuse. The relationship between the adjacent and the hypotenuse for this angle we're going to call the cosine of the angle. The cosine of this angle here is the adjacent divided by the hypotenuse. And the final pair we can choose, we've had these two, so let's go for these two. The opposite and the adjacent have a relationship for this angle which we call the tangent of the angle is the opposite divided by the adjacent. Now whenever this angle stays the same, the relationship between the opposite and hypotenuse, the sine of the angle, is always the same. For instance, if I just zoom in on my triangle, I can double or treble the size of those sides, but they're always in the same proportion to one another. So the opposite divided by the hypotenuse for a right angled triangle with this size angle is always the same, and we say that's the sine of the angle. Similarly, I've left the E off. The sine of the angle. The relationship between the adjacent and the hypotenuse is always the same. If this angle here stays the same, I could make a really small copy, or again zooming in, make a really big copy of this triangle, and the relationship between the adjacent and the hypotenuse is always the same. So the adjacent divided by the hypotenuse will always be the same, and we call that the cosine of this angle here. Similarly, the opposite and the adjacent, if I zoom in or out on this triangle, make a bigger or smaller copy of it, if I keep this angle the same, the relationship between these two stays the same, and we call that the tangent of the angle. And there are three trigonometric ratios. The three ratios are sine, which is opposite divided by hypotenuse, cosine, opposite divided by hypotenuse, cosine, which is adjacent divided by hypotenuse, and tangent, which is opposite divided by adjacent. If you need some sort of memory tool for this, I like to remember them like this. So, ka, toa. Sine is opposite divided by hypotenuse. Cosine of the angle, adjacent divided by hypotenuse. And tangent of the angle, opposite divided by adjacent.